Here I thought everybody'd be out for break. Well, it's a little survey of the technical knowledge in this room. Who has etched this circuit board here? Okay, how about this? Well, that's more than I thought would show up here. Okay, and that with it. Final thing. Go get one, said he with the most toys wins. All right, myself, the thing that usually goes to the territory. I said, unlike some people, I haven't gone to college and gotten a degree. I just kind of absorb any book I get my hands on and try to apply it. But things I have done among building machinery. Oh yeah, making stuff. The motors screaming, sparks flying into the night, all the good stuff. But it is a roundabout method I've gotten here because I started with computers. And I wanted to control machines with computers. And then I wanted to make electronics to enable that. And finally, I'm standing with a can of Burma Shave in a field with a razor going, why am I doing this? Yeah, don't shave the yak. Stick to some simple goal. And this is my first talk, so I tried to cut it down to something manageable. And there are lots of things. I could talk, if my voice would hold out, I could talk for 8 hours on machining. You could definitely talk for 8 hours on electronics. And I don't have to tell any of you guys how to do that. So you probably know more than I do. In fact, I'm pretty certain of that. That's the other thing. That what I have done is not the definitive way of doing it. It works. That's all that really counts. This is my first attempt at chemical etching. The cupric chloride. Not my favorite. But the problems I ran into, fumes for one. I was doing it in the middle of winter. I didn't want to open the door. The other thing is overspray from the aerator. Never would have thought acid would throw up spray like refreshed soda. Yeah. So my shop is already pretty crowded with what I do have. I don't need to store stuff, especially with other people in there. And I've got gloves and eyeglasses. That's not really, I'm trying to be more safety conscious than some people. But particularly, I don't have any way of washing off something on me if something happens. The other problems I've run into is all those listed there. That I've that's the thing, is working with chemical etching, it was almost good enough, never quite good enough. Something would always go wrong. There's always some variable I couldn't control. But I saw pictures of something like this, and I was going, oh, I want that. How can I do that? So I'm going to go over the basic tools you need. Basic process. Well, you guys already know the ETA end of part of it. What I managed to get done. Some things I really want to try as soon as I get home. Now, I've built a CNC machine, and it was very much like this. However, version 1 didn't last too long. I didn't make it good enough, so it was upgraded to version 2. Unfortunately, I have no photographic evidence or video or anything other like that because it was cannibalized for parts in the eventual upgrade to Wish I could show you the full picture here. My formatting's not right. That's a TAG mini mill, benchtop mill, and let's see, 12 by 6 by 8 work volume. It's got a 1/4-inch horse motor, and it's very nice for the price. As things go, it's one of those things that it'll get you started, but you're always wanting to upgrade it. So that's where the electronics part comes in. There are numerous little things you can add that turns a basic CNC machine to something that works very, very nice and pain-free. Now, Cartesian bots are just basic 3 linear axes all at right angles to one another. And when you're looking for one, get it beefy. The more mass and steel it has, or wood if you're building one. And there's a guy who has a wooden router and he routes circuit boards with it. The better. Power. The stepper motors, you can never have too much power. You can always overrate, but underrating is you're kicking yourself. That's all there is to it. And wider, that's one of the things. Looking at Mendel and Darwin Cartesian bots of the RepRap project, those are constructed to be small, compact, and easy to do. The fact that it's too light, or like too thin the rods, is one factor, but the moment of, I'm not a physics major, the leverage you can get too much torsion when your slides are too close together. If they spread it out and use a little heftier, it might be suitable. Now, the other portion. The RepRap project uses a microcontroller or embedded system to do its G-code interpretation. I can do a demonstration for you of EMC, and there are other products out there, Mach 3 being notable in Windows. A dedicated computer with simple I/O, namely a parallel port. Getting a little harder to find these days, but they do still exist, and the PCI card industry is still thriving. So you can have any amount of I/O is up to the limitation of how many PCI slots you have in it. And there are dedicated, more expensive hardware available. The combination of motherboards, video controllers, and other certain things don't always play nice for real-time control. Most notably, and I have a demonstration for after the show, is a Pentium 4 laptop. And no matter how you tune it, you're always going to get some random interrupt every occasion, and suddenly your nice little pulse stream for controlling your stepper motors will throw a couple hundred milliseconds of pause for some reason, because something is interrupting for power control or some other non-maskable interrupt. With the Ubuntu Live CD from the Enhanced Machine Control Project, or the RTA test suite, you can do a simple test to see if your hardware will play nice. And finally, if you're doing a dedicated computer for your mill, get a used mouse and keyboard. Don't try and use a nice one. You will have sawdust and metal chips and coolant, if you are so inclined, getting on into it. Now, the cutter bits for doing circuit board, I've heard of guys using a broken off circuit board drill and getting passable results. The cutter geometry, first of all, carbide. So you're cutting down to FR4. That stuff has got fiberglass in it, it's abrasive, and you are going to wear out steel cutters very quickly. There are certain sources for that. Generally, you don't really need to know what they're called. They marketed them specifically for PCB etching. Now, a good spindle. My TIG can go up to 10,000 RPM with its current pulley ratio. I hate it. The belt that they supply doesn't really like being tensioned tightly so that you don't get the slip. Then it starts to vibrate and you see it down at the cutter tip, and you don't think that it doesn't vibrate. We're cutting thousandths of an inch here, and you will see it in the quality of the cut. 10,000 RPM is really too slow for that small a bit. 30,000 or better. The other thing is, I've tried a Dremel. You can drill circuit boards with it. The bearings are just a little on the light side, and the plastic housing is also not stiff enough. And mount it securely. You're not going to get away with zip ties and duct tape here. Said, yeah. Now the work surface, as I have to do it because I have a simple CNC machine, the work surface has to be flat because I am not compensating in any other way. I'm relying on the accuracy of the machine to do my work for me. It's going to have to be a sacrificial surface because you don't want to drill down into, say, your table itself. And when I say flat, you buy material stock and you think it's flat. It's not. So aluminum can be bowed out 20 thousandths or more. Steel is whatever. It rolls out of the mill. There is stuff that you can buy, like a mixed 6 aluminum tooling plate. It'd be nice if you can get it. It's not in my budget. And if you already buy something flat, you have to align it up with your axis. It's painstaking. You're playing with shims and set screws. So I can't say it's a lot of fun. I just go with this. Get a plate, mount it down securely, and face it off. It's tedious, but there are things that can alleviate the tedium. One of them is we're working with computers. You can write a program to write a program. So you're working with G-code, it's simple simple motion description. It's fairly easy. It's like computer graphics. You just bunch of for loops and takes a while, but then you have a flat surface. Now the work holding, vacuum table. Be nice. But if you can afford a vacuum table, why bother with this? One method I'm going to try next is super glue. I don't know, I've heard it used for all kinds of things in machining forms, liquid vise or liquid hold down. There are guys that do sheet metal work on a lathe. They'll glue it up to a flat plate. Must work pretty good. What I have done is double-sided tape. Very cheap, easy to do. I haven't used acetone on it to release, but WD-40 will, if you let it kind of soak in, will spoil the stickiness, and you can slowly pry it off. Now this is where, for more of the noobs, so if you don't, do your own design. Just getting the artwork from people, you may not be able to modify it, especially if it's in raster format. And one thing that I found is when you're figuring out how this will work for you, your design rules may not be exact with what you laid out originally. You may have to make changes, add a jumper, or whatnot. Now this gets into want list. Most hobby CNCs are open loop. You don't have a set position. You're freely floating out there in space somewhere. You set a point based on where you're currently at. And relative coordinates work great. However, if you want to easily change stuff, having an absolute reference is better. And nothing's complicated about it. It's just micro switches at my level. Just problem is getting there and mounting them. Motor speed control. In order to reduce the amount of vibration, and the other thing is, we're in a open loop system. It doesn't sense torque or if you've got a stall condition. But one of the things with machining is if you can find the right spot as far as RPM and speed, it will, sometimes a little slower will work better than faster. And a router spindle will run at full out speed and will add more vibration. If you tone it down a little, it may work better. And along with the homing switch idea, a simple micro switch or even just an electrical continuity tester between the tool and a flat plate, chances are you're not going to have expensive tool change capability. Just putting a part in a collet each time, your tool is going to be at a different height. And when you do that, it's a guessing game, again, to come down and find out where you're at. A tool probe, it can be, with the system I use anyway, it can be scripted that insert it, come down, test it, you're done. It already changes the variables to know where it's at. Now naturally, you're assembling the information to make the circuit. Most of you seem to already know what that's about. Now, I like to use GPL EDA. I may be a masochist for that. I don't know, I like it. But it seems the more powerful tool is Cat's Off Eagle, not for the size that's available or even the library. What Eagle has over Gita is simply the PCB to G-code user language program. I list a PCB to G-code there, which is a GNU software project that's out there. It doesn't function that well. It does function. I've used it, and I started getting into the code, and I'm amazed that it worked for me at all. Particularly since they don't have very good documentation on the command line options. Now the G-code you produce, just port it off to your machine, and your machine does the work for you. I'm burning through this pretty fast. For those who have never done it, don't be afraid to try a few to see what works for you. Pick one and practice, and read the manual. There are a lot more editing features in the programs than you will probably find on the surface, and they will make your life easier. So particularly for me, since Gita has, what I like is being able to generate the symbols and the footprints for anything I find. And I do find a lot of stuff. I get parts surplus out of a box. I have to go dig up a data sheet on it, and it's actually gotten pretty good lately. I can go to a few sites and get something that was 15 years old. I don't know. When I started doing this, there was nothing. I couldn't get anything. Now, for those using Eagle, you already are there. So you've got your board layout, and you've got that. Painless. I wish it was. Not for everyone. I have another option I just found out before I was doing this talk. There are the Eagle PCB Power Tool at user language program. Supposedly I can take my Groover files and import them directly into Eagle. So I wish I'd known that back then. But for everyone else, well, I may get around to coding on that someday. And you can't see it, but you can also convert to DXF, SVG, and work it any other way you want. But the outcome is G-code, which is a basic description. Now, Gerber is a format describing the vector from photoplotters, the path a plotting aperture travels. This is not exactly what we need. G-code is a descendant of Gerber, but with a few things added for milling machines and lathes, and it gets used for all manner of things now. I believe the spec is up to 9 axes, which if you can wrap your head around that, so it can't simply convert one to the other. You're going to need an offsetting algorithm. First, you have to figure out what the space that the aperture travels, and then you have to say, my tool is going to traverse the space outside that. Now, G-code and assembly language have a lot in common. They are about down as far as you can go without writing ones and zeros. And no matter how much I work with it, it's never going to get easy for me to read it. The other thing with G-code is it's very simple. You can write a line and it will say go here, and it is go there. It is go there, do not pass go, do not collect $200. It is not like some other things where you say a line segment here to here. No, it's just go there. Doesn't matter what, if you screw up with one of your editing techniques, it will be, if you miss a step, it's not corner, it's diagonal right across the part you're trying to make. Yeah. There are things to do. You can, so because G-code is simple vectors, you can actually convert it back, and I've written scripts to do this. Convert it back to like a DXF, and you can view it again. But I don't have to do that anymore. The EMC project has advanced to the point where it has a GUI that you can see what your code is. And I'll always double check. So back when it was just numbers on a screen that you could see, you type a line, and all of a sudden your tool is plunging down into your shiny aluminum work table, and you can never reach the E-stop button fast enough. Never. So that machine is faster than you are. The basic, I've done this by hand. I hate it. Yeah. Figure out what it's going to be, and then making all the vectors that go outside it. Now, say, if you know how to code Python, you can do this wonders with this. But there's a wonderful thing. Gerber goes from these numbers, and you'll notice no decimal points. So that's an arbitrary measure to this. And that's nicely formatted. It doesn't have to be all nicely spaced out like that. And if you were doing this, you're going to go through these steps a lot. And it will vary. So your machine, based on what you have. And the run and monitor part, that's the longest. In a perfect world, for certain values of perfect, say you glue your board down. This is relatively to scale. There are certain bits you can use, depending on how accurate your machine is. Generally speaking, if your machine varies somewhat over the course of it, or your work plate isn't flat enough, a narrower angle bit is more forgiving. Height variation will not produce as great a width variation. But I'm not certain for the reasons for the wider angle. I believe it may be better quality. As it is, I have 60-degree cutters. They make them down as far as 30-degree, which I can't imagine how sloppy your machine would have to be to require using that. But we're cutting through copper that is at 1 ounce copper clad, about 1.5 thousandths of an inch thick. And that's all you want to cut. You don't want to get into the FR4 because that's abrasive and it will abrade even the tiny tip of carbide. But you are going to have to go down into it a little bit. And that's why proper alignment and work plate is so critical as things are, I am doing them now. I actually don't try too hard. I go down a little deeper than I need to. So I don't really care. So I just want it wide enough that I don't have like 24 volts arcing over. And again, I was not using the nicest tool for producing my G-code paths, so I had no extra clearing around or multiple paths to clear more. What I have been able to make so far is pretty amazing. I strip old components off of motherboards occasionally, and this one is mostly recycled parts. That's a real-time clock. It's an 8-bit bus, not the nice little I2C ones you have today. I had a lot of fun playing around with an Arduino to speak Motorola 8-bit bus timings and figuring out which pins I could use successfully. But getting to the underside, it didn't turn out too bad. You'll see on this side that the traces the isolation routing is a little narrower. On the other side, it cut a little deeper, so my alignment is nowhere near perfect, but it works at 5 volts. The other thing I made, and also more parts stripped off of motherboards, although the terminal strip and the L298s are all stuff I managed to find surplus new, just sitting in a box. And of course, no symbol for the terminal strip. I had to make one. The underside of it. Yeah, it's only 2 amps. Yes, I made my traces really big and fat. So I made them too big. They actually would sink so much heat away I had trouble soldering them. I had a 30 watt soldering iron. But I can guarantee you it will never overheat from the on the copper side. Now the problems, but I really cut this down. I thought I was going to take too long. Problems I did run into: vibration, too slow a spindle speed. Too slow a spindle speed, and belt vibration on my spindle. I don't know how to really quantify that. I have basic machinist tools. Supposedly there are indicators you can use on something like that to see how far it's vibrating down to microns. I believe that laser interferometer, stuff like that, but no such luck here. I just have to go, if it's too noisy, it's vibrating too much. On the H-bridge board, I'm not certain why I didn't have the same problem on the Arduino shield, but the copper bit was, the cutter bit was pushing copper around a little more than it was cutting it off. When it would come to the finishing corner, or where the 2 endpoints of the isolation route were supposed to meet, it would have a little whisker. And I was being paranoid to check that before I actually soldered parts on the board. So imagine my surprise. I'm looking at it under jeweler's loop, and I have shorts. I checked the code. Everything said the endpoints do meet. So yes, it's supposed to have cutting. Simple way of getting rid of that. 12-volt transformer and a couple leads. So it's as zen-like as popping packing bubble wrap. Also a little bit like a bug zapper. Lots of fun. The other problem, it is beta. So I don't know if I want to dedicate the time to developing on it, but so there's easier things to do and more important things to do. Now, getting more advanced, EMC allows for any kind of digital input. You can use it to synchronize motion to spindle speed, for threading without gears. You can use probes for tool height, for workplace location, or even workpiece location. This is all things that I'm making electronics for. I want to be able to have buffers so I'm not running voltage out here and accidentally fry my parallel port back in the computer, but also, well, that's the majority of it there. But also I want to be upgrade eventually to servo control, which takes a few extra things besides just an H bridge. This guy, PHK, I forget his name. This is one of those things that I found out just before I started coming in here. I'm going, why couldn't I have thought of that? This is probably more powerful than anything I could have thought of, because you don't have to align your table. You don't have to make it perfectly flat. You can just glue it down and probe a series of points, and you know how the topology goes. The other thing he did was actually doing a calibration run. I was simply running it and carrying it on a jeweler's loop with a pair of calipers saying, looks about that wide. Now he took it to the next step. You scan it and you measure how many pixels you've got, you know what you can get. Now the good parts of this, I don't have to be peering into a vat of acid and wondering, when is it going to be done? I don't have to have fumes coming off. I don't have to store it. I don't have to worry about my cat breathing. Well, I have a local mouser that has moved into my shop. I don't have to worry about chlorine gas in her. And it's capable of pretty good quality. So, I have done better boards with this than I have done with the chemical etching. Definitely not going to give it up. Eventually I want to do a surface mount. Through hole is easily done. For those of you who have it, it's a great thing to add on to your Cartesian bot usage. It's if it ever sits idle, you can always think of something else for it to do. That's the big kicker right there. My mill costs $2,000. It's not something that you can just say, oh, I'm going to get that this weekend. Or convince your significant other that you have to have it. If you've got a hackerspace that has one, or figured out a project, it's another great little tool to add to the list. It doesn't have to be a tag. It doesn't even have to be made out of metal. Wood works quite well. And so there's even a guy out there who's made a laser cutting and engraving machine out of plywood, of all things. The learning curve, I've taken a roundabout way of getting here. The machinery, electronics, and other whatnot, I've probably forgotten that I even know it. It may not be something for somebody who just wants to do one thing. I just want a circuit board. If it's that important to you and you don't want to learn preferably you know somebody that can help you out with it. I am a lone hacker hermit. I don't know anyone. I don't live near anyone. I don't live in near driving distance of anyone. So I have had to learn stuff on my own because that's all there is. And a tool like that, you can take the chemicals, you can put them up on a shelf, out of the way. A machine like this, it's taking up space, permanently. Say, I don't know, say, how many things that you really think, oh, it's just going to sit here a little bit. Before long, you will have it where I have to move this thing over so I have enough room for this machine to just be moved to operate. That is a liability, but you live with it. Any questions?
How are the maintenance costs for having a little home CNC 2D?
Costs a little bit of oil. Oiling it is, honestly, you can never oil it too much until you get it running off, but you might have, what's that? Oh, cutters, maybe 20 bucks a pack of 10, depending. PCB drills, you can open up any MSC, McMaster-Carr, all those catalogs to see how much milling cutters cost if you want to do other things. That varies greatly whether you want to go with import or premium grade carbide that can do high-speed machining in Mon-El. No, the cutters, based on the amount of horsepower and stuff, you don't need very expensive cutters. They will last you quite a while unless you're doing very abrasive things like fiberglass reinforced plastics. The lubrication doesn't take much. Maintenance as far as having to tear it down and adjust things for wear, unless you're doing a lot, you might not have to do it maybe once a year. And that's a good lesson anyway because you have to know what parts. Basically, the more you know about how it fits and how it works, the better off you are. Next.
Yeah, I was wondering, can you use this method to do multi-layered boards?
Supposedly you can. There's an outfit, a German outfit that LPKF, I don't know if anybody's heard of them. They make very expensive machines. We're talking like $15,000 and up. And they make two kinds, laser and regular router type. And the laser, they call it laser structuring, not laser engraving. Supposedly they have provisions in their method and setup that you can, I don't know if they through-hole plate it at all, but you can stack the boards afterwards. If you make vias, I don't know, so that's one of the things I was planning to do. Basically, if you can take a double-sided board and you can put a wire through it and solder on both sides for a via, you could theoretically do the same thing with solder paste and have a third board between and just sandwich together and let the paste glue everything together once you do like reflow temperature. That's strictly what you're willing to try.
Okay, I have a question. Batch PCB and those sort of discount services that send all these files over to China and then have the boards brought back. Have you done any type of like cost-benefit analysis to see, you know, if we're going to be spending a couple $1,000s in tools, well, maybe I can make 70 PCBs through batch PCB.
If you're going to do small batch production of the level of complexity when you start getting into through-hole plating and the other niceties, send it out. Okay. I'm not currently adventurous enough to try doing like through-hole plating because, like again, it requires extra chemicals and just other stuff that is not compatible with my existing shop. Milling circuit boards is not really something that lends itself to even a small batch because machine time is a lot more. You're better off doing a chemical etching or finding someone else who is more proficient with it. It is one of those things that CNC lends itself to, there's a higher initial cost to figuring out how to do it. There's even the cost of the machine time that's pretty big, but to do one more is fairly cheap. But that one, when you start going into like, say, larger than 10, try going with chemicals, because like with other people that I've seen it done, they can do the toner transfer method, and they can do an 8.5 by 11 sheet packed with as many circuit boards as you can fit on there, and there you go. Yes?
Is there any issue with the copper that's coming off the board? Does it pretty much vaporize, or do you have to worry about threads of copper marring the surface?
It's not even little threads, it's just tiny little chips. It's practically dust. And you just brush it off with a toothbrush and clean it off. If you really, let's see. If you really have problems with the bits in there, if you see where I've got larger gaps, I actually got in there with an X-Acto knife and I gouged the trace a little more just to try and dig that stuff out. This was the only board I had that problem with for some reason. The other problem, if it doesn't quite cut out, if it doesn't clear away enough between the traces, you will end up with a super thin little wire that might get pushed one side and or the other and be a big short. Probably won't run into that trouble with using Eagle software, because the extension that they added there has extra options for clearing larger around, say, like solder points, clearing extra between traces. Just generally, it is a nice bit of work somebody did. So if I ever meet them, I'll buy them a beer. Any others?
Like, how small of a pad spacing can you do? I think some of the stuff I've been working on is like 3 millimeters.
3 millimeters?
Yeah, or micrometers or something.
Let's see. Microns convert. Say 100 microns is 4 thousandths, roughly. Well, LPKF, their machines, they advertise it can go down to 4 thousandths of an inch, or 4 mils.
Well, I mean, what about the one that you built? How well did that do?
Oh, I'm guessing that I've got 5 to 10 mils separation. The guy, Chris Radek, whose picture, a good one. So that kind of quality is a fab shop. They can do 10 mil traces, 10 mil separation easily most these days. He's got at least that. And as far as I know, he doesn't even do the surface probing method to get their accuracy. He's just got a flat surface, and whatever the variation of the material, he's able to get that good a quality. Did I answer your question? Anybody else?
Thank you, Fritz.
Okay. I will have both those boards upstairs with a jeweler's loupe if anybody wants to examine them really closely. I will also have a laptop with the EMC2 software and some nice little motors to go whir-whir with if you want to see it in action. Thank you.